This conference will now be recorded.
Yeah, if you remember last time we are talking about heap memory, and for some reason I was not able to record the heap memory class. So uh, I got multiple requests from students asking to record the same session again. So we'll talk about the basics, and also like we'll also talk about some advanced concepts of heap memory today. So if you're seeing the if you're able to see my screen now, this is a sample application that I have created. Okay, so it is nothing but I just written this very sample program, simple program in Java, Eclipse IDE. You just need to open it. If you remember last time I was talking about creating a runtime object, right? So you just need to click on this sample app, and if you click new and Java project, a sample project will be created. And this is the main class, public class, and I have given the class name here. And after that, the public stat void main string args is the main method in our Java project. This is the main method for every uh, program that you write. And here after that, I'm trying to print the output as sample application for heap demo. Okay, and I have selected the data type as double 1024 and 1024. The reason why I have given double MB equal to 1024 and into 1024 is because if you don't give this, whatever the maximum memory, total memory, free memory, consumed memory that we get here, I see that values in KB. So when you want to see the exact utilizations for a better understanding, when you want to see that in MB, you have to do this into 1024 into 1024 so that you will see the utilizations of these heap statistics in MB now. Okay. Even if you don't give this double equal to some 1024 into 1024, you'll still be able to see the statistics, the heap utilizations. Okay. So, but you will get the details again in MB, sorry, KB. So you have to convert that into MB, and then you have to understand how the memory has been utilized. Okay. So I have created a runtime object. Runtime are equal to runtime dot get runtime. Don't worry about what is this get runtime and what is this max memory, total memory. There are some default methods and objects that are inbuilt from the Java Eclipse directly. So this max memory, whatever you see, this blue in color, right? Max memory, total memory, free memory, consumed memory. These are all memory related uh, methods that are already there in Eclipse IDE. Okay. So, oh, sorry, Java. So, what I'm doing here is I'm writing system.out.println max memory. So this I'm calling this method using the runtime object that I have created, and I have created this program. So after write, you can take a screenshot of this. This is a simple program. So you just need to right click on it, and if you click on run as Java application, you will see this metrics. Okay. So when we talk about this, take a snapshot of this one. So this is one way of knowing the heap utilizations of your host by writing a simple program. And other than that, if you start about heap memory, right? So again, we'll go back to the basics. For every JVM, how many heap areas are there? How many heap areas are available? Only one, right? So you might have another question like when the heap area will be created. On starting the JVM, whenever we start the JVM, the heap area will be created. How the heap area will be created? The heap area will be automatically created by default. Whenever you start your JVM, the heap area it gets started by automatically by default. And third question is which data is stored in JVM heap area? Okay, all the objects are stored in heap area, and all the corresponding instance variables are part of these objects. So automatically, all these instance variables with for all the objects will be saved in the heap area. Okay, and in this heap area, whatever objects you have, okay, whatever objects you have, all the objects will be accessed by multiple threads. Again, I'll tell you what is object, what is thread in the next class. When we talk about thread dump analysis, I'll tell you what is thread and what is object from the basics again. Okay, that is why uh, that is why it is called for accessing by for the objects that are accessed by multiple threads in the heap. So the reason why it is called shared memory and global memory is because all the multiple threads that you have inside the JVM that reside in JVM, all the objects are accessed by these threads. Okay, and I already told you every array in Java is an object again. So all the arrays are objects only, and all the information of all the arrays is also stored in something called heap area. And I don't want to overload you or I don't want to confuse you. The one line of heap is all the object related data gets stored in heap area. That is the first point. Even if you remember when we spoke about method area, right? That is the first area, memory area that we have. We have five various memory areas in JVM. The first one is method area, right? If you remember the method area will have all the class level information. It will have all the current different information like modifiers information, constructors information, fully qualified name of the class, all such informations, whatever the different declarations that you have written as part of your program, all that information is stored in method area that is called class level information. So now this class level information is moved to heap area. When it moves to heap area, all the class level information will automatically converted into object level information. This class level information to object level information conversion will be taken care by JVM internally. You need not do anything from your side. So this conversion it will happen from the JVM internally. So again, this is the basic, like all the objects, all the arrays, all the instance variables of the corresponding objects. For the very first time an object is created, there is some actual memory that it takes. That actual memory consumption will happen in something called heap area. Okay. I have already given you an example saying that we can to know the heap statistics like used memory, free memory, maximum memory, everything. You can write a simple Java program to display all these statistics. For any Java application, if you take, right, any Java application, if that Java application has to communicate with the JVM, we have to use a runtime object. What I mean to say here is a Java application can communicate with the JVM using runtime object. So there is another question here: how can we get or how can we create a runtime object? The simple answer is runtime R equal to runtime get runtime. This is the runtime object. Okay, and this is available in this package java.lang.runtime.getRuntime. Okay, so once we create this runtime class, now we can ask the memory statistics in the program. Okay, with the help, because you are communicating again, this application now is communicating with the JVM using something called runtime object. So we can get all the heap statistics, right? So now, can anyone of you tell me what is the difference between what is max memory or what is free memory or what is consumable memory?
Free memory is the available memory,
Okay,
and the max memory is the JVM's capacity. That is the configured memory, total memory.
right. So, I already told you one example last time in the last class, which was not recorded. So, let us assume that I have 500. That is the maximum capacity of this classroom. Okay, of a classroom where I'm teaching. So, 500 is the maximum capacity. The total capacity of the classroom itself is 500 people can accommodate, can sit 500 chairs. Okay, but if we have only 100 chairs, okay, Now this 100 chairs is nothing but the initial memory. Okay, so in this initial memory, out of 100 chairs, if 60 chairs are occupied, the remaining 40 are nothing but free memory. Got it? So the consumed memory is nothing but initial memory minus free memory, which is nothing but 100 minus 60. Again, it becomes 40, right? You understood the point? So 100 minus 40 will be 60. Sorry. So now you have to understand these basics. The max memory, total memory, free memory, consumed memory, so that you will get to know how heap is utilized. And when you try to increase your heap capacity settings, you have different configuration settings from a WebLogic server, from your application server. You can go to some paths. You can edit with Notepad++, and there are some parameters where you can set it up, and accordingly you can increase the heap, or you can increase decrease the other parameters like hidden, survivor 1, survivor 2, younger generation, older generation, metaspace. You can give all the different parameters there according to your requirements, and depending upon what different exceptions or errors that you get from your load testing, you give all this, you change these values accordingly. Okay, and the max memory, it returns the number of bytes of maximum memory that is allocated to the heap, and the total memory is like, it will return the number of bytes of total memory allocated to the heap. Total memory is the word, but initial memory is the word that we use from the heap statistics, but we call it as total memory. And when I talk about free memory, it returns the number of bytes of free memory present in the heap. Like if you see all the metrics down here, you can take a snap. If you're not able to take a snapshot, you can take a snap using your mobile. Okay, and this heap capacity settings, right? Heap is a fixed amount of memory. So you
I
can
think
yes.
we are losing you back and forth. In a few minutes.
Not okay. Yeah. The voice is breaking.
It's a low and high, kind of
I'm sorry.
oscillating.
My voice is still not okay, but yeah, I'm connecting my headset. Allow me a minute. Sorry.
Uh, Question, RK.
Yes, please.
So max memory is 1772 MB, right? And total is 121. So total memory means so it is the total that is allocated for the JVM, the entire, isn't it? Let's say the entire.
See, total memory is also called initial memory. Yeah. The max memory is different. Max, you will have too much of memory, but total memory is like whatever I told you, right? Total memory is nothing but if you have few objects in the place now, like 100 objects, okay, and 60 of them are, occupying, the remaining 40 are nothing but free memory. So free memory is always less than total memory.
Okay, because it was little
Confusing, right?
I got it now. So
Yeah, yeah. We will talk about that as well. Okay. So, uh, so it is possible to set the maximum and minimum heap sizes, and you can set this XMS and XMX values from your WebLogic application server. I mean, depending upon what application server, web application server that you're using. So you can directly go and increase and decrease depending upon what exceptions you get from your load testing, and what are all the different memory fluctuations you see. Accordingly, you increase or decrease. But you need to understand the best practices of how you have to give the heap. Okay, basically when you try to install some product, or when you try to run some endurance test for a period of time like 8 to 10 hours or 16 hours, you need to understand how a heap has to be defined. Okay, for that I'll also tell you the best practices. So we already spoke about the JVM memory model, and when I start with something called heap memory, garbage collection is a part of heap. Okay, heap and garbage collection will decide the complete performance of the JVM, any JVM. Okay, I, I'll tell you how they are related. And we already spoke about the different components in JVM memory model, and we will talk about where the objects will be stored, and what are all the different GC algorithms that we have. What is minor GC, what is major GC, and what is GC pass time, and there are different GC types. So going forward, on Monday we will talk about how to analyze GC logs and all. GC is a complete different topic, so we will talk about GC on Monday. So when we are talking about JVM, to monitor JVM, we have separate tools like JVisual VM, JConsole, JProfiler to understand the complete picture of heap, thread dump, and the JVM health, to check every individual monitor with respect to all the classes, methods, and the data types that you have in a program. To monitor all of them with respect to memory and CPU, you need to use these tools. You need to use any of the tools. Don't think like JVM would be sufficient or JPro would be sufficient. All the tools work in a similar way. Okay, JConsole, JVisual VM, JProfiler. All these three tools are they're very simple. If you know this JVM concepts and other stuff, right, it will be very easy for you to uh, I mean, work with profiling activities. Now, if you look at this diagram, right, what do you understand from this diagram?
Yeah, we can various memory areas in the heap.
Okay, most of the performance engineers, uh, uh, I mean, they are asked with this question: what is hotspot heap structure? How many different areas of memory structure, memory layers that we have in heap? So before going to that, again I'm repeating it for you because I don't want to confuse you. Components in JVM memory model are: the first one is heap, there is second one is stack, there is something called method area, native memory, and PC register. I already showed you that in the JVM architecture, right? Heap, when you say heap is the place where all the objects and their references are stored. This is the only one line for heap. What heap will do is, heap will store all the objects and their references. Okay, specific memory is inside the JVM is allocated to the heap. So when I talk about objects, when I say the objects are stored in the heap, here what I mean here is all the static variables, the static objects, the corresponding instance variables, and I already told you every array in Java is also an object. So all these references to the classes which got loaded, all of them are completely stored inside the heap. It means that they reside in the heap. Now after they get stored in the heap, what happens to an object is the main point here, right? So we'll talk about that more in detail. I already told you about stack areas. Stack is nothing but the local variables that are created for all the methods that are stored in the stack. You being a performance engineer, do not worry about all the other stuff like a full stack Java developer. What you have to understand from stack is the local variables that are created for all the methods that are stored in stack. Okay, all the method arguments and parameters of all that methods are also stored in stack. That's all. Because even if even any performance engineering interview they will ask only what is the difference only between the stack and heap. That's all. You need not tell how they are stored, what is the method argument, what is the method parameter that is stored in the stack. No one will ask you that. If you have some good amount of experience or knowledge in core Java, so a simple answer for Java stack is the local variables of all the methods are stored in stack. That is nothing but stack. When we talk about method area, in method area, all the compiled class files are stored. Okay, and in we already discussed about this native memory. In this native memory, if you have any legacy applications, there are some code snippets which are developed in C++. Okay, all other language specific codes reside in native memory. Okay, so this PC register, what this PC register will do is it tells every thread what it has to do next. PC register will hold all the instructions of that thread and it will instruct the thread what to do next. That's all. Now
Sir,
we have.
excuse-
I am hearing a lot of disturbance actually. Can all of you place your call on mute, please? Because
question, RK.
yes, please.
Yeah. So in the PC registry, is the address of the next instruction is going to store, or the entire
No.
instruction is going to store?
No. It will hold an instruction for every thread. If you have 100 threads, for every thread you will have a piece register. So it is telling each thread to do what in the next activity that it is performing, right? It will hold the next instruction. It tells every thread what it has to do next. Hello?
Yeah.
You there?
So I'm sorry, actually. So I thought it is the say only the for that instruction there is a pointer that is going to store in the PC registry. That's what I thought. That's the reason I was just clarifying.
Okay. Yeah, because we can still go and talk about it. I mean, we can talk so much about it, but our agenda is different. So I'm not talking more about other areas. I'm mainly focusing on heap. Okay, from a performance standpoint of view. So anyhow, there is one nice article that is very well written in DZone. I'll share you that article today. Before you understand, before you go with all these concepts, you need to have a complete understanding on how JVM works. What are all the different things that you have in JVM? How each component in JVM architecture will work. So uh, what are the different memory areas that we have and how they work? But here our main focusing area is heap. Okay, because we are mainly dealing with the performance, and all the performance related issues happen with only the objects, methods and classes. That's all. And all the method level tracing and information will be taken care by any profiling tool. But when we talk about the objects, right, objects are the most important part. In objects also you have different types of objects, like there are different types of references. Before we talk about objects, we also need to understand about the different types of references that we have. There is something called weak reference, strong reference, phantom reference, and there is another reference. I don't remember the name of that reference. We have 4 types of references. I'll tell you how to deal with all these references in the next class. Okay, so but when we talk about heap, you need to understand this heap structure. If you see my screen now, whatever I'm sharing, the hotspot heap structure is talking about 3 different generations. One is younger generation and older generation and permanent generation. First, I'll explain you at a very high level, then we'll go, we'll talk in detail. Okay. So now what is younger generation here?
The newly created objects. are going to store in the heap.
Okay. Okay.
As the GC happens, then there is a movement between from hidden to S0, then S1. Then after few cycles of the GC, then move to the 10.
You're right. So I'll tell you the basic point. I'll tell you. You have three generations. One is younger generation, and one is older generation, and one is permanent generation. You got to do nothing with permanent generation. You need to worry about younger generation and older generation. Younger generation, you will have three different spaces in younger generation. The first one is called Eden. The second one is S0, and the third one is S1. The S0 and S1 are called survivor spaces, and I'll tell you why we have two survivor spaces. Okay, and then older generation. Okay, now younger generation is the place where all the new objects go in. Okay, all the objects that come for the very first time, they reside in the heap. Okay, I mean to say, like, all the objects that we get with the very first time, they are created in the younger generation. Once the younger generation is filled with all the objects, okay, I'm talking about the Eden, the younger generation, all the three different spaces. Once the younger generation is filled up, right, with all the objects that they come in, the garbage collector immediately kicks in, and this is called minor GC. Okay, whatever the garbage collection that is happening on younger generation is called minor GC. Okay, whatever the garbage collection that is happening on older generation is called major GC. Now tell me, what is garbage collection? Any idea about what is garbage?
JVM GC is a thread that deallocates the memory of the unreferenced objects within JVM.
Okay, any other answers? I want you guys to be more interactive so that you will understand this concept. That is why the reason I'm repeating it for 2 to 3 times, the same thing again and again. I mean, my expectation is to make everyone to understand about this heap concepts from the basics. So now tell me, what is garbage? We have
Yeah.
so many in the call, right? So many.
Yeah, in the short term, garbage is a trash, right? Basically, trash means unused objects that will be taken care. That is one thing. With respect to the GC policies, whether it's a serial, parallel, or depends on that, there is a mark and sweep. Then that is going to happen, and it is done by the GC.
So basically, we'll go from a very basic level. Okay, garbage is in a one line. It is collecting useless things, right? In programming, unused objects are collected by garbage collector. Okay, and this GC is responsible for this garbage collection. I'll tell you an example. This is the need or purpose of garbage collection. In the older languages like C or C++, okay, programmer is responsible for creating the objects by, I mean, he can, in the program, he can use some new keywords, like if he wants to create some new new object, right, he will use a keyword called new. If he thinks that if the programmer thinks that the object that he created is no longer required, then he will create a keyword called delete, and he will write the name of the object, and he manually does it, right? So in the old languages, programmer is responsible for destroying the objects. He uses some kind of keywords like create, delete, some keywords to destroy all the useless objects. So that means we are deleting all the useless objects manually by using some keywords. Okay, now if the programmer need to create an object, if you want to write some code snippet, if you want to build some application, he will create an object. So when he is creating an object, he will take very much care when he is creating it. Okay, like for the very first time when he wants to create it, he will create it very carefully, he will use it, and once the work of that particular object is completed, after completing the work with that object, the programmer has to do what? He has to destroy the object, right? It means that he's freeing up the memory and he is reclaiming the memory. So at the time of destroying the object, the programmers always, they neglect to destroy the object. I mean, he might think that he can destroy object some later point of time and he will not destroy it. So when he is neglecting the destruction of these objects, I mean, because of the developer's negligence, entire memory gets filled with useless objects which are no longer required, which are of no use, and free and to create the new objects, sufficient memory may not be available, and the entire application can become unresponsive, or it will go down. It will hang for a while. It will literally halt because of all these memory problems. When I say these memory problems, out of memory error is a very common error in older languages like C and C++. Now, if when I talk about Java, now in Java, Java is very faster now, very fast, very responsive. In Java also, the programmer is responsible for creating the new object. But if the work for this object is completed, now the programmer has to do what? Again, he has to destroy the object. He has to free the memory. That used to happen manually in C or C++. But here in Java, what the Sun system people did was, programmer is not responsible for destroying the objects. Okay, these people in Java from Sun Microsystems, from Sun Systems, sorry, they have created one assistant called, I mean, this assistant runs in the background for destruction of useless objects, and this assistant is called garbage collector. You got it now? You understood what is garbage collector? Okay,
Yes.
just because of this garbage collector, the chances of failing Java programs is very less, especially with memory problems, is very rare. In a single word, now garbage collector is responsible for destroying all the useless objects. Now, if you have another question like why it is destroying the useless objects, it has to destroy the useless objects. It has to free the memory for other new objects that, I mean, for other new objects that are newly created. If they want to make use of this heap or JVM, whatever the objects that are useless inside the JVM, which are residing in the JVM, which still have some strong references, which are not able to, which even garbage collector is not able to remove all those uh, uh, unreferenced objects. Now your intervention is required to see why it is taking too high response times. So what I mean to say here is, now garbage collector, it kicks into every different area of the heap. Okay, it tries to free up the memory of all the useless objects. Okay, and sometimes, right, as I told you, there are something like strong references, weak references, phantom references, depending upon the reference type of the object it has. And if the object is still not referenced, is still not required, but the garbage collector is not able to garbage that unused object, at such times it will create something called memory leak, because that object is no longer required, that is no longer used, but still that object is there, is occupying some memory in the heap. It is continuously eating the memory. Okay, 2 MB, 3 MB, 4 MB every time your user is accessing. Then it is nothing but, in such situations the memory leak will happen. Again, I'll tell you what is memory leak from the basic in the going forward. So that is why the reason having garbage collector in Java, that is why Java is called a robust programming language. Okay, and there is no such thing called directly removing the object. I told you, right, in the last class. you cannot you cannot forcefully make an object to be garbage collected. You cannot directly, no programmer or no performance engineer or no one can from the team who has some knowledge on from the programming side, who has access to different programs in the application, he cannot directly go and delete the object which is no longer being used or no longer referenced. We call it as a useless object. We cannot directly delete it, but there are some different ways. Okay, there are some good ways where you can make an object to be eligible for garbage collection. I'll explain you that very clearly. So now when I talk about the younger generation, it is the place where all the new objects are stored. It stores all the corresponding information of the objects. Okay, so once the younger generation is filled with all the new objects, now the garbage collection immediately comes in. It performs a minor GC, garbage collection. Once these objects which don't get garbage collected, you have to remember this point. Whatever the objects don't get garbage collected, what does it mean?
They are still using.
Right?
They are
It
still
means
in use.
that they're still alive and they have a reference somewhere again. They are referenced, right? They are used with some other objects. They have dependency with other objects. They're still being used. Okay. Once the objects which don't get garbage collected, it means they are survived objects, they are living objects, they are referenced objects in the young generation. They are moved from young generation to old generation. Okay, this is the basic concepts. The objects which went through different life cycles, lots of life cycles of garbage collection, but still survived, all the objects which got survived, they are moved from younger generation to older generation. Okay, that is where the long lived objects go in. Whichever the object is continuously referenced, or whichever object is continuously alive, or it has some strong reference for a very long period of time, it will be moved in this minor GC. In this minor GC, it is not garbage collected. The object is not removed from the younger generation, and that is now moved to older generation. Understood? So the GC which happens in the older generation, which is called tenure, is called major GC. Okay, the GC which occurs or which happens on the older generation part is called major garbage collection. Now whatever the GC that happens in younger generation on Eden, S0 and S1 is called minor GC, and older generation, whatever the GC that happens on older generation is called major GC. This is also called the total garbage collection is minor GC and major GC. Okay, now if I talk about Eden space, all the new objects are there in the Eden memory. Okay, right? All the Eden, hello,
Yeah, you can
Yeah, we
continue.
are able to hear.
okay, I thought it got disconnected. My Wi-Fi is down. Okay, now before we talk more about heap again, I have discussed a few points about heap in the last class, which is not recorded again. Now tell me, when do you take this heap dump now? This is a very important and powerful concept for every performance engineer from 1 year to 15 years experience. So you can try giving your own answers. That is fine. You can be wrong or right. That is also okay. But these are all basic questions. Now tell me, why do you take a heap?
So when we see any out of memory exceptions,
That is the first point. You're right. That is the very first point. Java heap space, the common error for the very first error that you see, every time you see out of memory error, exception, you need to take a heap. Okay. that
But
indicates
but an
that in,
anticipatory we
yes.
can do before that also, right? We can able to monitor.
No, it is not that you cannot do it or you should not do it. You can do it at any point of time. But this is a direct indication, direct saying when you see a out of memory exception, the first thing that you have to do is you need to look at the heap, and you need to look at all the different objects which are eating high amount of CPU and time. Which object is not garbage collected, where it is spending too much of GC time. There is another thing called GC pause time. I'll also tell you about that. Okay, so basically this out of memory exception, this will indicate your Java based application ran out of memory. Okay, basically Java heap depletion. So you also keep a note, you also need to keep this in mind. Every JVM has its own memory capacity settings. And if you have 4 to 5 JVMs, each JVM has a different heap structure. It is not one single heap structure for all the JVMs. If you have multi JVM based environment with the multi-tiered environment, you need to check for all the, you need to monitor all the JVMs. You need to look at all the different JVMs, and you need to give the appropriate heap settings for all the 8 or 10 JVMs that you have in your architecture. Okay, so when do you take a heap? First one is out of memory, and for what symptoms? For what are all other symptoms you take heap?
We can able to see how the heap structure also, like mentioned, the sawtooth pattern. We can able to see how whether are there any objects that are still increasing or something, and how the in the Eden how it is happening, and then how it is moving. Based on that also, especially I would say depends on that the pattern. We can easily assume that there is something going on.
Okay.
Yeah, by then let's take the heap dump and see are they happening, sitting the objects or continuously they are growing up or something.
Okay. No, and
in
apart
case of
from that, you will see some. Sorry for interrupting. So you will see some symptoms, right? Some kind of performance issues. What are the symptoms before, if you want to take a heap, right? What symptoms you take a heap?
That obviously we'll see at the front end our UI side also the response times. That is the most of the time, and yeah, so the response times.
Okay.
Then look at the CPU also, because when the more usage that usually loads on the CPU also, right?
Okay.
Whenever the
Multiple-
available memory goes down, we will consider taking heap dump.
Perfect. Any other answers?
multiple GC cycles are happening.
Yes.
Major GC.
Excellent. Right. You're right. So yeah, that is the most important point. So the first symptom can be some sudden failure of the application, which is not not responsive, or it can also be some major slowness of your Java application. That is nothing but response time. If it is 13 seconds, 17 seconds of a specific transaction, you need to look at your heap. So as I told you, there is an error like this found in any of the program or console log, java.lang.out of memory error dot java heap space. This is the error that you basically see. And someone told me in the last, it is high CPU utilization. Okay. He told me that number of excessive GC cycles. So when the JVM is getting close to run out of memory, the garbage collection will happen much more frequently, and it will increase the high CPU utilization. Okay, garbage collection happening. So that is how it works, right? You have 100% memory. 40% is filled now. The garbage collection started. It is every time it is deleting all the objects. Now it is coming to 30, 20. So, but still the new objects are coming in, they are occupying some memory in the existing heap, and the garbage collection is running. And when it is slowly increasing to 60%, the garbage collection will happen more frequently now. If it is when it is 40% of the heap occupied, it is happening 2 times in 5 minutes. When it is 60%, now it will happen 3 times or 4 times in 5 minutes. When it is 90% occupied, the remaining objects will wait to come into the heap. So the objects are not getting deleted. The garbage collection is still trying to act excessively. It is trying to run more number of cycles. It is trying to collect all the garbage because the heap is 85 to 90% utilized. So every 1 minute or every 30 seconds, the garbage collector kicks in and it is trying to free up the memory. It is trying to clear all the garbage or all the unused objects. So when the percentage of available memory is decreasing on the total memory, the garbage collection will happen more frequently on the heap. When the garbage collection is happening more frequently, this will increase the CPU utilization. The only side effect of CPU utilization is excessive number of garbage cycles, right? Now they can ask you excessive number, is it minor or major? Basically, minor, the memory space that you have here, this is 1/4 of the memory size in heap, basically the survivor space. So the objects, most of the objects which are not referenced or which are not used gets deleted in the first phase. So the younger generation will not suffer. So younger generation, something is not used, it gets deleted, it will reclaim the memory. But older generation, the object will go through some n number of garbage cycles, garbage collection cycles. It can be 10 or it can be 15. So now these objects are called strong referenced objects, which are long-lived objects. So when major GC is happening, it will collect a very less percentage of unused objects when you compare it with younger generation. Okay, so that is why the reason major generation, sorry, older generation, the major GC which will happen on older generation will take a lot of time if you compare it with younger generation. Okay, minor GC will take a very less amount of time to complete the garbage collection cycle, but major GC in the older generation will take a lot of time and it will have a big performance impact. Okay, understood here? So the most frequently asked question to any performance engineer is, what are the reasons for high CPU utilization? My memory is increased, so CPU is increased. Or some transaction is taking so much of time, high response time. Now my CPU is increased. Some of the area functionality of my application has been not responding, or it is taking too much of time to load. Now my CPU utilization is increasing. So where is your valid answer here? If I ask you what is the reasons for CPU utilization, I am not convinced with your answer. Now what is your answer for high CPU utilization?
Because there is a lot of GC cycles is happening, right?
Right?
So
yes.
That leads to the CPU.
Now, when the GC cycles will happen, now you need to explain what I have explained. You need to explain the entire story when you say this GC. I'm not saying that. You need to explain the entire story. You need to be very specific. Your explanation should be a logical one when you try to answer why you have this high CPU utilization. I mean, when you're answering because of excessive GC cycles that are happening on my heap, the CPU has been increased. Now you have to give a logical conclusion on that. That is what I'm trying to explain you. Okay.
Okay.
So
Okay, I have two questions.
yes, sir. Yes.
Where to see how many number of GCs are happened? First one, and the second one.
You can see that in the profiling tool.
Okay, and the second one is this GC will happen in Eden S0 and S1, right?
Right.
One after the other, all together.
No, altogether, Eden S0, S1 completely called as younger generation. It will consider as a one actually, as one area, and it will run the minor GC.
Okay, and we cannot And we cannot control the number of GC happens, right? It is system based.
You can do that actually, but it all depends on your programmer, how efficient he is writing his code. You can have that control on some different parameters. You can set it up, because you cannot set some 50 garbage cycles for 5 minutes, right? Again, it will impact your performance. There is one option where you can set the GC number of cycles that it will go for, and you can also, that also depends upon the number of the type of garbage collection algorithm that you use. I'll explain that: serial, parallel, concurrent, mark and sweep, garbage first. We have some high performance garbage collector mechanisms, algorithms. I'll explain you that. You will understand there.
So, what is the better time? What is the better interval for each GC?
You can, there is no direct conclusion, because it depends upon the infrastructure that you're using and the number of users that you're pushing in a specific time. If if you see, uh, yesterday I have gone through an article from Neotis. That was the world's highest number of users that they have performed. It is they have conducted a test with 2 million users. You can imagine, for 2 million users, you can think of what algorithms they can use, or how many number of GC cycles they can use. That all comes with the architecture design and benchmarking and baselining. There is some architectural team who decides that.
But
However,
one suggestion we can give is, as soon as this young generation is filled up with all the objects, right?
That's what that is how it will work. But you have to make sure that everything is happening in the right place at the right point of time. Because if for example, if the memory is not getting freed up in younger generation, it stops there itself, right? The memory completely occupies there, and no object will come in.
Yeah.
Promotion of the objects moving from young to older generation is a different point. But the very first stage, younger generation is getting filled immediately, then it is of no use. You can directly say that it is because of inefficiency of the code, it is because of some bad design in the application, it is immediately affecting my heap, the first phase of my heap. No objects are survived. Okay, so there are a few scenarios like where you need to understand all this concept. Yeah.
So, what is the memory proportion between younger, old, and permanent?
Yeah, we'll talk. So we're still in the basics. So I'll tell you what are all other parameters that you have to define for read, and how much you have to give. S0, how much you have to give. SN, S1, tenured and permanent. Now from Java 8, I guess this permanent permgen is now called metaspace. Okay, the name has been changed. This is old diagram. The permgen is called metaspace. Now I will tell you. I'll explain you in detail in the next class, like how much each area of heap has to be allocated. Okay, before that we'll complete this one. So there are a few possible causes. Okay, there are some fixes you can avoid all these errors. The first thing is you have to give some appropriate heap capacity settings. Using default settings will help you to some extent, but defining a heap, this is the most important point. Most of the people still ask you, how do you define your heap? On what basis you decide your heap? If I am testing for 8,000 users for the next 1 month, how do you decide your heap on your infrastructure? That is a valid question, right? We'll talk more about it in the next class. That is a big concept. So you need to give the appropriate Java heap settings, XMS and XMX values. You can also use default settings, but I don't know to what extent that they will help. Every time the default heap settings will not help you. Okay, even in the first 1 hour or first 40 minutes of your 4 hours test, you can see error saying that out of memory or application going down, high CPU spinning, a lot many issues. And Java program memory leaks. So it is like essentially building up all the Java objects over time, which are not released by the garbage collector itself. Then there is a high possibility of having a memory leak. I'll tell you what is memory leak again. So excessive application memory footprint. The main point why I highlighted this point is because during the architecture design or during defining the heap structures, heap limitations of every individual area in the hotspot heap structure. So you need to also understand the application memory footprint, and you need to set it accordingly. If application footprint is very high, is too high, or we are trying to work too much on a single process, in this case, your memory gets filled up and you will see a lot of memory issues again. So there are various diagnostic tools like JVM Verbose to analyze GC logs. You have Java Visual VM, JVisual VM, JConsole, JProbe, JProfiler, and other APM technologies. Okay, so you need to increase the heap size. You need to monitor and profile. You have to resolve your memory leaks, and you cannot optimize and you cannot reduce the Java application memory footprint. There is a separate team. You need to talk to them and you need to understand how the footprint is decided for Java heap. You can directly, because if you take any of the companies, right, any companies, any projects, even today, most of the service, I experienced this scenario with most of the service based companies. So uh, there are few applications which are developed in the year 1992 or 95. No customer wants to touch it. Okay, don't touch it. Don't touch my legacy code. Whatever you do some cosmetic changes on top of it, you wrap it up and you send it to the customers in the name of release 6.2.2 2020, which is the latest version. That is a crap basically. Okay, if you understand it correctly, doing some cosmetic changes, putting the same stupid product inside the box and packing it with a gift wrap and sending it to the customers is a crap, right? And there is no question of improving the performance at all until and unless you touch it, you optimize, or you try to reduce the duplication, or if you try to reduce the redundancy in the code, or if you try to move to some emerging tech stack, you must be knowing what is monolithic architecture and microservices based architecture. You can go to my LinkedIn. I have written an article on microservices based architecture, performance testing for microservices based application. So the monolithic architecture which was developed in the year 20 years ago or in the early 90s. So what they want is they will have one presentation layer, one business layer, and one database layer. Everything will be there in everything will be there in one single tied architecture. And if something goes down, the complete system will be down. Now adopting this microservices architecture, so what will happen is every layer will have a separate microservice. Okay, so if you want to make changes in any of the microservice, it will not give any bad impact on the other existing microservices. They will work, they will be up and running as usual. Even if you bring one particular service down, you can bring that down, you can make changes in minutes and you can bring it up. So if until and unless the customers don't move to that kind of they don't move to from monolithic architectures to microservices based architecture using some containers, dockers, and orchestration concepts, they cannot improve the performance. They cannot run anything faster. They cannot deliver anything faster. So the reason why I explained you all this concept is because if you want to know the memory footprint, you need to get in touch with your application team. You need to ask them how you have decided why you want us to give this heap for this test. Can you explain me why? The day when you ask this question, you will become a strong performance engineer. Okay, and services based companies will always limit one's potential, every individual's potential. They will have some different dedicated teams. You will not be touched. You will not be given access to any of the server. You cannot write some script in LoadRunner, just running it, executing it in Performance Center or JMeter, master slave configuration or anything. Publishing a result is not real performance testing or engineering. When you run your test, look at all the graphs.
understand all the graphs, especially with the memory. Every time I ask this question, every candidate answer in the interview is, sir, my bottleneck is memory. What you monitored? I have monitored memory, I monitored CPU, I monitored disk, I monitored bandwidth, I monitored network. It's a very simple resource utilization matrix. Now tell me what you have monitored, what issues you have identified. This is my question. And if I talk only about memory part, I can stop anyone from selecting in the interview. I'll talk only about memory. I can. It's not that I forcefully or I'm not a psycho to deselect. I mean, I cannot direct jump onto a conclusion saying that he's not the right fit. If I only talk about memory, he will fail in his interview, even if no matter if he is 15 years experienced. So I am recommending everyone to have strong basics on memory, how CPU will work, how operating system will work, and how network or how disk will work. When you understand these concepts, you can, when you see a metric called disk reads per second, you will easily understand if the disk reads per second is low and disk writes is very high, you will understand the bottleneck very easily. That is how the way of learning performance is. That is how it starts. Learning performance engineering, that is how you can start learning. Okay, so the common solutions, this is the point where we are discussing optimizing and reducing the Java memory footprint. You need to touch base with all the teams to understand all these things. Okay, and you need to split the workload of all the Java based applications across different Java processes, because if you look at most of the objects and methods or classes, it will refer only one specific Java process, which will create more stress on that particular process, and it will take too much of time, too much of load, too much of time to execute, and it will result in bottleneck. So developers has to take care to split the workload accordingly to all the different processes that we have in the Java application. If the distribution across the Java processes in the application of all the objects and classes that they define is appropriate and efficient, then chances of seeing Java performance issues is very, very less. Got it? This is a very basic of heap structure. So I'll also talk about the next class is also will be on heap. I'll also talk about stop the world events, the permanent generation, and how we'll decide how much each area of hotspot heap, how much value you have to set for each value, each area that we have in hotspot heap structure. So the reason we are going very slowly is because this is a complicated concept, and we will talk about XMS for setting the initial heap size, the minimum. The maximum is XMX, and there is also called XMN. You must be knowing, right? Most of the people don't know what is XMN. Okay, for setting the size of a young generation, rest of the space goes for older generation. The total younger generation is XMN. I'll make a note here. Okay, what is XMS?
The default initial.
It is a minimum heap size, right? XMX is
maximum.
There is another parameter called what is it? Is okay.
XML.
XMN, right? What is this?
It is the
Got it? Once you give this value, the remaining space goes for the older generation directly. If you give 3 GB, 3 GB is for XMN, the younger generation. I'll show you the diagram again to avoid confusion. Okay. XMN is the total value for this younger generation, Eden, S0 and S1. Got it? Okay. Let me forward you from the document here. This will help you for your interviews. XX PermGen. There is a. Where is my notepad? Okay. What is this? Any idea?
It's a meta space.
This is the size for permanent generation. Okay. Initial size. That means that minimum size. Okay. Minimum size of PermGen. What is this one?
Max.
This is one of the important one. Okay. Survivor ratio. Can you tell me what is this?
Guess it is a S0 versus S1.
You're right. So it is like you are providing a ratio between the Eden space and a survivor space. Okay. For example, if younger generation is some 10, okay, and if you give the survivor ratio as 2, okay, if I give 2 here, if I give 10 GB, for example, survivor ratio, if I give 2, 50% will be for Eden and 50% will be for S0 and S1. Okay, and again 50% of survivor space, 2.5 will be for S0 and 2.5 will be for S1. Now I'm sending that document to you. 1 minute. Oh my God, what happened? Okay, these are all the important metrics that you have to change for heap. Now tell me, where do you set all these parameters? One last question for this session.
In the JVM parameters.
Okay, tell me, where is your JVM in the architecture? We'll ask randomly this time. Where is
When
your
we
JVM?
execute a Java program, we can give these arguments as optional parameters.
No, that is fine. That is fine. But I am setting this Java app settings where which path I'm accessing now, which server I'm accessing. Where do I set these parameters?
If it is
Anyone?
The app server.
You're right. App server. Which app server is it?
The one that has the code, the one that stores the code.
Let me show it to you a bit to avoid your confusion. Oh my God. Don't. Which server? You know which server is this one?
This is WebLogic.
Right. Set domain env base domain. Okay, this is the path. Okay. One more data. Can you tell me what is this one? I highlighted one area, right? What is this one?
Those are the JVM parameters, right? You just mentioned XMS, XMX. So
These are all JVM parameters. Okay. So this is not installed properly. So I'll reinstall it again and I'll tell you where you have to set it. Okay. But this is the place where you have to set your heap settings. If you want, I can ping you the path. You have to go to the WebLogic. You have to go to Oracle middleware, Oracle home, user projects, domains, base domain. In the base domain, you have to go to bin and there is a file called set domain env. If I ask anyone, where do you set this heap parameters, your interview is gone. Where do you set your heap? Heap is nothing but you have to set in this document. Okay. And this is the application that I will show it to you. Okay.
Okay, this is Windows, right? So if it's a Linux also, you do the same way.
No. If I talk about Linux, I have to talk a lot about it. If I go, I don't have any issues with showing it on Linux. Okay, but if I go to Linux, I have to talk about. I have to start from the basics. But I'll tell you how to. Because if you want to go to that path in Linux and if you want to open that one, you need to know some commands to edit, to update, to set that values. You need to do all that stuff. Even if I use Linux, right? As I told you, I will use WinSCP. I showed you, right?
But we will be discussing that also, right? Isn't it?
But no, as a part of this program, I'll discuss it. No doubt about it.